Howdy, for PreCal, it is Ms. Kosh. I am continuing 1.11 from Mr. Passwater's notes, but I'm actually working backwards. So I had a video where I talked through binomial expansion. So go find that one. And now I'm going to do long division. So if I had designed the AP curriculum, I would have done it a little differently. But, you know, they didn't ask me, so that's great. So I don't know why I'm saying all that. Okay. Oh, you know what? I disagree with how he wrote this. I think what we need to see here is that that f of, okay, so what happens here? Let me talk you through. I'm making the video off of long division because I teach it earlier in the year than it fits into the curriculum. So here we go. Okay, this is saying if I take a function f and I divide it by a function g, I will get some answer, q of x, but I might also, okay, hang on. I'm not finished here. Okay, let's jump to this one. If I'm back in elementary school and I have 676 and I divide it by 21, I would say, okay, how many times does 21 go into 67? I would say it goes in there 3. And then I come back and multiply and I get 63. And I subtract and I get a 4 and I bring down this. How many times does that go in? It goes in 2 times. 2 times that is 42. When I subtract, I'm left with 4. So a remainder of 4, a quotient of 32. And what did I do with that 4? Well, the answer, it's 32 plus 4 over the 21 that we had. Okay, so if I'm going to divide polynomials, I take a polynomial f, I divide it by a polynomial g, I get q, which is the quotient, plus some remainder that is now being divided by what I was dividing by. Over here, it was divided by 21. Okay, this bleeds through. Okay, so when we have this is, I think my kids were familiar with this from Algebra 2. You take a polynomial, divide it by a polynomial, you get an answer plus the remainder over whatever you were dividing by. But this is not how AP PreCal likes to write it. They like to come through and multiply everybody by g of x. So when you look in the PreCal stuff, you see, actually this is not quite right because it shouldn't have this g here. Because when I multiply, those cancel and these cancel, and I have q times g or g times q in whatever order you want. So I think there's a little typo here, but I have typos too, so it happens. Okay, so let's look at this one. If I have 6x squared plus 7x plus 6, and I divide it by 2x plus 1, then this is going to go in 3x times. I like to make sure my columns maintain their integrity, that anything in that column is a like term. This gives me 6x squared plus 3x. I come along, subtract, 4x plus 6. Oh, look, 46, 4x plus 6. Excuse me. Okay, so plus 2, and multiply here, I get not a 2, I get a 4. 4x plus 2, and when I subtract, okay, I didn't say myself, subtract, that's gone. This gives me 4. Oh my goodness. Okay, so the quotient is this 3x plus 2. My remainder was 4. And so my answer is that this, I have this 6x squared plus 7x plus 6 over 2x plus 1 would equal 3x plus 2 plus 4 over, what was I dividing by? 2x plus 1. However, this is not how AP PreCal would write it. Let me see if I can find a blank sheet of paper. What they would do instead is they would say 6x squared plus 7x plus 6 equals, well, one of them is 2x plus 1, and it multiplied by 3x plus 2. And then when I do that, then I have to add 4. Okay? And so this is probably what you saw in Algebra 2, or at least how they teach it at my school. And then this is kind of the AP PreCal way of doing things. Cool. Hope that was helpful. Let's see. He then says, use long division to find a slant. Well, I'm kind of waiting to teach that to you. But we can use long division. So, yeah, well, I'll just do long division, and then we can revisit this when we get to to rational functions. Oh, did we just divide this? We sure did. Right? Oh no, it's not the same problem. It's just very close. Okay, very, very close. All right. Let's just practice the long division part. Okay, so 6x squared divided by 2x gives me a 3x, and then multiply that back. 6x squared plus 3x, and then I have to come through subtract, subtract. That's gone. This gives me a negative 2x plus 5, gives me a negative 1. When I multiply back, I get a negative 2x minus 1. Subtract, subtract, and this gives me a 6. So what happens here is that this graph, h of x, is going to look like 3x minus 1 plus, what was it, 6 over 2x plus 1. So what happens is that as this graph goes, as we start looking at the end behavior, as this number gets ridiculously large, either positive or negative, 6 divided by something ridiculously large. It's like, say I have $6 and I share it with the whole world. Well, that you're like, Miss Kosh, that's not very generous. You know, like $6 divided by, are we 8 billion people? I don't even know, 7 billion, whatever. But it's practically zero. It's not technically zero, but it might as well be. So this goes to zero if this is a ridiculously large positive or negative number. So your graph starts to follow the shape of this part right here. Okay, so my kids were not doing slant asymptotes quite yet in the year, but eventually we will. And so the slant asymptote would be the line y equals 3x minus 1 is our slant. Okay, I think the rest of this really deals more with rational functions, and I'm gonna wait to do that because we're doing all the polynomial stuff first, and then we're gonna do rational functions. All right, like, subscribe, comment, let me know if you have any questions and if I can help you. Good luck, go practice.